One good day, pre-algebra. We are wrapping up unit number 1 with least common multiple. Similar, yet the exact opposite to greatest common factor. So what is a multiple? What is it? You know what? Actually, before we define that, let's go down to this section here, where we compare factors and multiples, compare and contrast what they are. So we talked about factors. What are the factors of 12? What are the factors of 12? Anthony. 6 and 2 are factors of 12. What else? 12 and 1 are factors of 12. What else?
4 and 3.
4 and 3 are factors of 12, right? And what makes those numbers factors? Why are they factors? Why not 5? Why not 10? Why not 15? Why are they factors? Tristan?
Because you can multiply them and get the same exact number.
Yes, they go into 12 evenly. Okay, and we kind of organize them by their factor pairs, their factor buddies, because 2 times 6 does equal 12. So now, what are some multiples of 12? Multiples. 1 is not a multiple of 12. 1 would be a factor of 12. 1 goes into 12, right?
24.
24 is a multiple of 12. Is that the first multiple of 12? No, what's the first multiple of 12? 12 is, right? And then 24, and then 36, and then 48, and then 60, and then 72, and then 84, and I could continue on forever, right? Notice my wording in how I asked these two questions. I said, what are the factors of 12? And then what are some multiples of 12? Why did I choose those words here? Yeah.
Because in the factors, there's only a limited amount, and then in the multiples, there's a infinite.
Exactly, right? Factors, there's only 6 of them. That is it. Those are the only numbers that go into 12 evenly. Whereas with multiples, because we're getting bigger, right? We're adding 12 over and over and over and over again. That can go on forever. Okay? So one difference between factors and multiples, factors, there's only a finite number. Multiples, there's an infinite number. Okay? Factors are all 12 or below. Multiples are all 12 or higher. Right? So now let's go back up to our definition of multiple. How would you define it? What is a multiple? I mean, factors of 12 are numbers that go into 12 or numbers that can make 12. What are multiples of 12? Sure, it's basically what 12 can go into, right? 12 can go into itself, it can go into 24, it can go into 36, and go into 48. A multiple are numbers that a given number can make, right? Our given number is 12. The numbers 12 can make 12, 24, 36, 48, 60, 72, 84, etc., etc. Okay? So that's the difference, okay? And what's confusing to kids, and I completely get it, is that, greatest common factor, you hear that word greatest and you think big numbers, when actually you're dealing with numbers that are 12 or below, right? Least common multiple, you hear the word least, small numbers, when actually multiples are bigger, okay? So it's that kind of opposite meaning there that trips kids up. So I completely get it, but we're going to try and buck that today. Here we go, finding least common multiple. We're going to use 6 and 10. And the first method I'm going to show you is the listing method. Just like we listed factors for greatest common factor, we're going to list the multiples of 6 and 10. So under M stands for multiples. Give me some multiples of 6 and 10. Yeah, 12. And I'm going to start with 6 there, just because everyone. 12, and then just say them. Good, 18, and then 24, 30, 36, 42, 48, 54, 60, 60. How do I know when to stop? You don't know when to stop, right? So that's one of the disadvantages of the listing method is that you might not know how long to go. Okay, so I just listed a bunch there. We got all the way up to 90. Multiples of 10, I'll get you started. 10, 20, 30, 40, 50, 60, 70, 80. How do I know when to stop? Okay. Well, if we're looking for least, meaning smallest, common, meaning they share it, they both have it, multiple, what I'm looking for here in my lists are numbers that show up in each of them, just like we do with the greatest common factor, right? I see a 30 in both of them, I see a 60 in both of them, a 90 in both of them, right? So our common multiples that we have so far are 30, 60, and 90. We'd get more common ones if we can continue to go, right? But those are the three that we have in the list here. And what's the least of those? 30. So 30 is the least of the common multiples. Okay, notice that 30 is larger than both 6 and 10, even though we use the word least. The least is referring to the multiples, okay, which get bigger. But that's how you use the listing method. What are some disadvantages of the listing method? I'm going to show you a method and then tell you why it's horrible. What are the disadvantages? Yeah. It could take a long time, depending on how large your least common multiple is. Mia? Could potentially go on forever. Hopefully I wouldn't be that cruel and give you one that went on forever, but there's potential for that. For it to go on forever? I mean, literally not forever, but for a long time. Okay, Anthony?
Could there be decimals?
No, factors and multiples do not include decimals or fractions. They're only integer values. Okay, good question though. What if you added wrong? What would adding 6 isn't quite as easy as adding 10. If we added 6 wrong, if we thought 18 plus 6 was 22, just because sometimes we make mistakes, what's that going to do to our list here? It's going to mess it up, right? And so there's the potential where if you mess something up, you might not know where the mistake happens, but then you might not even realize that you did. It was going to throw everything else off. Okay. The advantages of it are it's pretty straightforward. I just add 6 over and over again. I add 10 until I find one that matches, right? But it does have a few disadvantages as well. Okay. The other method is the table method, which looks very similar to what we did with greatest common factor. It actually starts the exact same way. We're going to make our table. We're using 6 and 10. Okay. And we're going to use the exact same process we did for greatest common factor, which is why this method might not be the one for you because you might get the two confused. Or if you know you set it up the same way every time and just know the difference between the two, maybe this is the one for you. That's why I show you 2 of them so you can pick. I like the listing one better, or I like the table one more. So we're going to start the same way here. What is a factor of 6 and 10? What goes into both 6 and 10? Nolan. We're looking for factors now. Yeah, like I said, this one, it's very similar to greatest common factor, which is why maybe it might not be the one for some of you, but 2, okay? So we're going to take out a 2, and just like greatest common factor, we're going to divide both 6 and 10 by 2. And that's going to give us in our second row 3 and 5. Okay? Now, if we were doing greatest common factor, we'd be done here now, right? What would our GCF be? 2, right? It's 2 because we can't take any more numbers out of 3 and 15. So we look at our blue column here, okay? And we know it's a 2. But in least common multiple, This is where the method differs. Instead of just taking that 2, once we run out of numbers to take out of this, we make an L for least common multiple. Isn't that brilliant? An L for least common multiple, and we multiply all of them together. What's 2 times 3 times 5? 30, right? The same 30 we got from the listing method up above. So the difference between the two table methods is that when least common multiple, you also multiply the numbers you've got left over. Greatest common factor is just straight down. Least common multiple, you make that L and you multiply everything. How we doing? Did I totally confuse everybody? Do you have a question?
Yeah.
Yes.
Since it's like the greatest common factor, if you were, do you only do it once, like since you would divide it by 2, or would you do it until you just can't divide?
You would do it until you can't divide anymore, just like greatest common factor. The only difference is then, when you're all done, you make the L. Okay? All right. Let's try 15 and 21. And let's use both methods here. That's why I gave us so much space to work. Starting with the listing method. What are some multiples of 15? I will get you started. 15. Then what? 30. Then what? Shout it out. 45. 60. 75. 90. I don't know when to stop, so I'm just going to stop right there. Don't?
I said stop now.
Oh, stop now. Okay. Okay. Let's go to 21. What are some multiples of 21? I will get you started. 21. Then 42. Then 42 plus 21 is 63. Then 84. Uh-oh. Do I have to go back to my 15 and keep on adding? Yeah, because I've now gone further than I went with my 15. Here I only went to 90. I'm already at 105, and nothing is matching up yet. So let's go back to 15. What's 90 plus 15? Oh, well, that was convenient. Okay. 105 shows up in both lists, and so 105 is going to be the least common multiple. Okay. Again, listing method, pretty straightforward, but there is the potential, especially when adding 15 and 21, to perhaps make a mistake and then get off. Okay. Table method. (15 and 21). What can we factor out of 15 and 21? Nolan, a 3. We do that. Divide by 3, divide by 3. We get 5. And we get 7. And we cannot do anything more. 5 and 7 do not have any factors. So now we make the L. We multiply everything together. And 3 times 5 times 7, spoiler alert, is 105. 105. Okay. So, initial reactions. Who is a fan of the listing method? Ooh, who prefers the table method? Wow. Okay. All right. Okay.
What do you prefer?
What do I prefer? If I have to write it out, I would probably use the table method, but most of this I can do in my head. But if I had to write it out, I would do the table method. Yeah. Who has questions? The most important hands I want to see right now. Who is unsure what's going on? Okay. Well, let's raise the stakes. Let's go to 3 numbers now. We'll start with the listing method again. 9. Then 18, 27, 36, 45, 54, 63, 72, 81, 90. We'll stop there. We'll go 10 out, see what happens. Thank you, Nolan, for all that information. Now go to 15. 15. 30,
45.
45.
60,
You just copy our list from the one before, right? 75.
90.
Oh, I got a match. Ooh. Let's see if 18 brings us home, or if we have to go further, right? Because it has to show up in all three sets. You know, it can't just show up in two of them. It's got to show up in all three of them. So 18, right? I wouldn't say 18 is my least common multiple because it shows up in two of my numbers. It's got to show up in all three of them. So I have to keep on keeping on. 36 would come next, and then
54.
72, and then I was too excited. I couldn't wait for anyone to say it. 90. There we go. Shows up in all three lists. The least of the common multiples, the first one that shows up in all three lists is 90. Let's go to the table method. We got to make an extra column here because we got three numbers to work with. We got 9, 15, and 18. What can we take out of all three of them? Nolan? A 3. Okay? So divide by 3, divide by 3, divide by 3, and that gives us 3 below. 15 divided by 3 is 5. 18 divided by 3 is 6. Now, here's another difference between greatest common factor table method that shows up when you've got 3 or more numbers. I can't do anything with all 3 of them, but what can I do with 2 of them? Anthony? Josie? I can multiply 3 times 5 times 6. That's unfortunately not going to give me the correct answer because, I shouldn't say that. It does, but it doesn't fit the L thing here because what can I take out of 3 and 6?
2.
I can, not a 2. I can take a 3. Okay? Even though I can only do it from 2 of my numbers, I still get to do it. Whereas greatest common factor, it's got to be every single one, every single time. With least common multiple, if you can do anything with any of the numbers, you do it. Okay? So I'm going to take out another 3. 3 divided by 3 is 1. My 5 doesn't change. That's still going to be a 5. And my 6 divided by 3 is 2. Okay? Now, there's nothing I can do with 1, 5, and 2, any of it. So now I go to my L. It all gets multiplied together. 3 times 3 from my column, times 1, times 5, times 2, and that gives me 90. Okay? Josie was correct in saying that if I had multiplied my 3 by 5 by 6 here, I would have gotten 90 also. That's just a coincidence. Okay? That won't happen every time. So we do want to break it down further to get that L. All right? Questions on this? Comments, concerns, complaints, compliments, congratulations, or criticisms? Okay, all right. Let's practice with a couple of these. I'm going to let you do them on your own. Of the 8, no, let's start with the, let's go on here. Of these 4, right here, okay, actually not that one. These 4 here, pick 3 of them to do. Okay, you can work on them either by yourself or with a table mate, but do 3 of them. You can use whichever method you prefer, listing or table. You can switch it up, whatever you want. I'm going to pause the video so I can walk around and help as needed, and then we will reconvene and see how we're doing. All right, we're back. So 199 is the first one. Anyone who didn't get that and want to talk about it? Not sure why. Questions? Okay. 25 and 35. What'd you come up with? Yeah. 175. Anything to talk about there? $80 and $50? Anyone want to share what they got for that one?
400.
400? Anything to talk about there? Man, this is just practice, right? If you're running a new play for a sport and you've got a question, certainly you'd ask your coach. Wait, I'm supposed to run over here, right? Okay, ask me. I'm like your math coach. Should get a whistle. But you're all good. Everyone is least common multiple expert. Okay, all right. 8, 14, and 16. What'd you come up with for that one? 8, 14, 16. 112. Questions? Okay. Well, I will trust that things are going swimmingly, especially with this one here. I'm going to do this one, the table method, just because it's the 3-digit one and it's got that little extra twist to it. So if you did the table, you can follow along. If you didn't do the table, maybe jot it down here just so you have an example. What can we start by dividing all three numbers by? What's a factor of all three numbers, 8, 14, and 16? They're all even, so of course we can start with a 4 doesn't go into 14. 2, okay? So 8 divided by 2, 14 divided by 2, and 16 divided by 2. You could start with 4 if you only did it with the 8 and the 16. So that could be a first step, but typically we start with what can go into all three of them. And 8 divided by 2 is 4. 14 divided by 2 is 7. 16 divided by 2 is 8. Now we're not done yet, right? Because we can still do something with 2 of these numbers. What is that something? Mia, we can divide 4 and 8 by 4. We can skip over the 7 because this is least common multiple, and we can do that. And we got a 1, a 7, and then a 2. Right? Now we're done because nothing else can go into 1, 7, and 2, so we take the L, and we're glad to do it. 2 times 4 times 1 times 7 times 2 equals 112. Excellent. Okay, so with that 3 number, especially the table method, there's that little extra quirk to it that you can still do stuff, even if it can only work with 2 of them. And that's one of the differences between this and greatest common factor. Okay, word problems. What were the phrases that we talked about that clued you in for greatest common factor? That when you saw these phrases, you saw these words, you knew you were using greatest common factor. What were those? Yeah. Identical, and there was one other one too. Identical was one. Using all of the items was the other one, right? Identical and using all of the items. For least common multiple, what you're looking for is something that repeats itself, okay? You're looking for a phrase like how long, something that's going to happen in the future, right? Because multiples, they get bigger. So we're looking for when something will happen again. And then, something that repeats itself. Like how long until something happens again. Okay, that's what we're kind of looking for here. Not as cut and dry as greatest common factor, but definitely some hints there. So this first one, Pat, Mark, and Chris take off from the starting line on a racetrack at the same time. So they start together, right? They're starting together, and we want to know how long it will be until they are all together again. That's least common multiple. Something happens at the same time. When will it happen again? Pat can run a lap in 2 minutes, Mark can run a lap in 5, and Chris can run a lap in 7. So we're looking for the least common multiple of 2, 5, and 7. Okay? You can use the table, you can use the listing. Take a minute to do that now. Let me know what you come up with. What's the least common multiple of 2, 5, and 7? The listing method is going to take a long time for this one because of that 2, very small increments. So table method might be better for this. Anyone confident in what they got? Anything we can do? No. So what does that mean we do? Just multiply. Okay? Not really an L here. We'll make it one just to fit the narrative there. But if there's nothing you can take out of them, then you just go straight to multiplying. And what's 2 times 5 times 7? 70. Okay? So in 70 minutes, poor Pat has to run 35 laps, 2 minutes a lap. But in 70 minutes, they'll all meet together at the starting line again. Okay? Let's look at the third one here. 2 stoplights, both turn green. Something happens at the same time. At 1:05 p.m., it takes one stoplight 20 seconds to complete a cycle, which means to go from green to yellow to red and then back to green again. And it takes the other stoplight 36 seconds to complete a cycle. At what time will both stoplights again turn green together? Least common multiple. Something happens at the same time, and then when will that happen again? Those are your phrases. Those are your hints for least common multiple. What are we finding the least common multiple of? What are we finding the least common multiple of? What are the numbers that we're using here?
20 and 36.
20 and 36. We don't use the 105, right? Because that just tells us when it happens. It's not when it will happen again. But 20 seconds for a cycle, 36 seconds. Where's my 36? 36 seconds for a cycle. List, table. I'll do the table just because it's kind of more quirky than just the straight up listing method here. Only 2 numbers to worry about this time. What can we take out of both 20 and 36? We can take a 2 out. They're both even, so might as well start with 2. 20 divided by 2 is 10. 36 divided by 2 is 18. Are we done? No. What can we take out of 10 and 18? 2 again. So 10 divided by 2, 18 divided by 2. That gives us 5 and 9. Anything we can take out of 5 and 9? No. So now we do the L. Right? And our factors, 2 and 2, times 5, times 9, 180. Okay? Now, with word problems, the other thing that makes them difficult is that you have to answer the question being asked, right? The question isn't, what's the least common multiple, right? The question is, at what time? So what does that 180 represent? What's the unit? I mean, 180 isn't a time. You can't have 180 o'clock, right? But what's the unit on that 180? Seconds. And we know that because it was 20 seconds and 36 seconds in the question. Now, how much time is 180 seconds? Let's see, 60 seconds to a minute. More than 2 minutes and 40 seconds. 3 minutes exactly, right? 60 plus 60 plus 60 equals 180. So 180 seconds is equal to 3 minutes. Still not the answer because that's not a time. At what time will they all turn green together? Will they both turn green together again? Here's where we go back to that 105. If that's when it first happened, it'll happen 3 minutes later. Everybody? 1:08 p.m. Who knows what that is in military time? 1:08 p.m.
PM. It's
1:08 p.m. Kira? 13:08. Since it's after 12 noon, you just kind of add 1:08 to 12 and you get 13:08. You don't have to put the PM then, because that's why it's military time, so that you don't have the confusion. Is it AM or PM? 13:08. If there's a question like this on your test and you write the answer in military time, I'll give you an extra credit point because I think it's cool. Okay. So to calculate military time, if it is the afternoon, you add whatever time it is to 12. And like you keep on going, you know? So what time in military would it be at 11 p.m.? 11 p.m. Penelope? 2,300 hours, right? 12 plus 11, 2,300. So extra credit opportunity there if you do it on the test. All right, that was I did it. We did it, folks. It's 8:29. We're done. This entire objective is due for homework on Monday. You've got 2 more word problems. I tell you about my favorite days of the year, my Buffalaco days. And then some review down at the bottom. All right, that's iMath.
Don't forget to like.